Now I am going to explain a small point but very important point in kinetics, and it is called as half-life period, or simply it is represented as T half. And by half-life period we mean the time period in which the amount of radioactive substance is reduced to half of its original amount. So see, it is defined as the time taken or time period in which the amount of reactant or amount of substance, even it can be in any reaction, but it has been the part of nuclear chemistry or nuclear physics, but here it has been given, is reduced to half of its original amount. So the point is, what is the requirement of taking half-life period? Actually, all the radioactive substances, they are under a process of degradation or decomposition at very slow speed, and the time period taken by them is very, very large. Time period taken to decompose is very, very large. So as a result, to have some significant meaning, this concept is used. Nothing. So very simple point, because the lifetime or life period is several thousand years in most of the cases of radioactive substances. That's why it is taken as a reference point for the half-life period. For example, you all must know, during the World War II, the two beautiful cities of Nagasaki and Hiroshima, they were destroyed by the Americans by dropping the atom bomb. And so the cities, they were ruined. No human, colony or no human is allowed to live, because the radiations are still there in the soil, everywhere. And radiations, they are alpha, beta, gamma rays, they are highly energetic. They can change the genetic pattern or the DNA as a result. So on the Hiroshima Nagasaki day, just in the month of August, it is celebrated. So around first week, so the persons go there to have for very small time period, then they return back. So this is the reason. Now see, for example, C14, C14 is an isotope of carbon, and it is radioactive in nature, and its P half is equal to 5,770 years. 5,770 years. So the meaning is, if you take 4 gram, let here be C14 4 gram sample. So after 5,772 years, it is reduced to 2 gram. Then after again 5,770 years, it will reduce to 1 gram. And after 5,770 years, this becomes the starting point for this. So this, after this years, 1 gram will be converted to 0.5 gram. So you can imagine that this and this. So this 4 gram is reduced to 0.5 gram in around, this you can imagine, almost 20,000 years. So this is the concept of the, in the basic point of the half-life period, and it has been incorporated in the rate law equation for the, this rate law expression to study about any chemical change. Now to start further, this rate constant is equal to 2.303 upon T log. Now A naught upon A, and so this K is a rate constant. This T is the time taken, time period in completion of reaction. This A naught is the concentration of reactants, at T is equal to 0, and this A is the concentration of reactant after time T. So as here if we take this, if it will be there, so this will be reduced to half. So we have, so after T half, after half-life period, this will be reduced to half. So A will be equal to A naught by 2. So we'll put here or write down this T half is equal to 2.303 K log A naught upon A naught by 2. So it will be cancelled out. Now as a result of this, we'll have this one. So finally, we have T half is equal to 2.303 upon K log 2. And so on solving we have the point. See how. So on keeping the values of this on solving, so we'll have 0.693 upon K, and so this is the value of, this is the mathematical approach, this is the mathematical expression to find out the half-life period. So this half-life period can be determined for any order, and so this is the rate constant. So this is the formula to find out the this half-life period. So if half-life period is given, so we can also calculate the rate constant. And so from the rate constant we can know whether it is first order, zero order or any order reaction. So that's why it is very much significant. And the point is why we study in chemical kinetics. So answer is very simple. Any reaction can take place in any time period. So to calculate the concentration of the reactants or to calculate the concentration of the products or what product will be formed after what time period. So as a result, this is very much significant in the chemical kinetics. So this is all about the concept of half-life period and its applications.